All right, welcome to Bath Tech and the safety overview for the welding program. First thing is, in the shop, you're going to be exposed to a lot of hazards and a lot of new equipment, things that you're just not familiar with. You may be exposed to something that you think you're familiar with, like a drill press or a grinder, but I don't want anyone operating any equipment of any type in the shop until that they've been properly trained. A lot of people do things at home that are either wrong or unsafe, and it's your job as a student to come out of this program understanding how things are expected to be done in industry, okay? So that means safety is going to be paramount, and we're going to go over those expectations starting right now. All right, the first thing to recognize is that the shop itself is going to be run similar to a shop that was under the guise of OSHA. Now, technically, I am under OSHA. As an instructor, I'm an employee here, so the school is managed by OSHA, and you will take an OSHA course as a part of this program. Currently, students are being enrolled in the OSHA 10-hour safety course for construction. And throughout that program, you'll learn what the general expectations are in terms of construction sites. Those scenarios will exceed what you'll see here, but we have to make sure that when we're working in the shop that we're working to those general expectations. One of the things that you're going to have to become accustomed to, other than waiting to be trained on something before you use it, because that would always be the expectation in industry, is that if you get injured, no matter how small that injury may be, you want to report it. It will be very likely that at some point in time during the program, you will get a burn of some form. Welding produces sparks. You may have a spark go down your shirt or in your sleeve. Maybe you've got a hole in your glove. Maybe you take your gloves off for some reason and you forget and you grab something that's still hot. That burn may seem very minor, and in fact it may be very minor, but you want to get in the habit of reporting it. It is not out of the realm of possibility to slip or fall in the shop or on a work site and pick yourself up and think, wow, you know, that kind of startled me, but I feel okay. And then the next day, find that your back is killing you and you can barely move. It's important that you let your supervisor know when something like that's happened so that you can potentially be covered by workman's comp. So as an example, if you hurt your back at work, say you slipped, you fell down, maybe you just didn't completely fall down, but you kind of had one of those instances like when you're on the ice and you kind of, whoa, you catch yourself. And you find out later that you really pulled a muscle and you have a hard time getting up and being fully mobile the next day. If you were to go out on comp and you didn't report that injury, there's no way for the company to know that you actually did it at work. It's hard to imagine, I know, but there are people who will hurt themselves at home, splitting wood or whatever, and then come to work the next day and claim that it happened at work so they can be covered by comp. So it is very important that you let yourself know that those types of injuries, no matter how small, need to be reported. Here at the school, typically you would get a burn or something similar. Maybe you get even if it's just a sunburn because your neck area is exposed because your jacket isn't set up properly. That may not really show up until the very end of class, or you may not notice it until the next day. But let us know that that's happened. We'll take care of it, and we'll send you down to the nurse, get some burn cream. They'll fill out an accident report, or they'll have me fill one out actually, and that will be part of the record here at the shop, just like it would be on the job site. So if you have an injury, please make sure that you report it. All right, in terms of workplace behavior, this is a shop, and it's basically a big, gigantic classroom. In your regular classes, horsing around, running around the shop, acting like a teenager, is just not really acceptable. that type of behavior isn't acceptable in a math class or a history class. It's not acceptable here, and for similar but different reasons. A, it's unprofessional and it's annoying, and also it just increases the possibility of an injury. The floors in the shop are very smooth concrete. They can be very slippery, especially when they're covered in grinding dust. Okay, so we keep these floors swept so that they're not as slippery. I have had students fall down. They've been running around in the shop and slip and fall, and the floor is very, very hard. You could hit your elbow, you could crack your back of your head open, you could sustain a serious injury by falling on concrete. And I know that we don't like to think that that's the case because they don't happen all the time, but when those injuries happen, they're generally very serious. So horseplay is generally unacceptable in a professional environment, and it is definitely unacceptable in a shop where injury or even death on a construction site would be a realistic possibility. All of the equipment in the shop requires training. You may have come into the program with some experience on your own, and you may have had very good training, but I don't know that. So every piece of equipment in the shop requires training. From where I'm standing right now, I can see the shear, I can see our bandsaw, our CNC machine. We have a grinding booth. We have grinders that range from small 2-inch pneumatic or rotary burrs, a die grinder is commonly called, all the way up to a very, very large heavy-duty 7-inch Makita grinder and a 14-inch stationary cutoff wheel. We have pipe bender in the shop. We have vertical band saws. I mean, Oxy-Fuel cylinders here behind me for torch cutting operations, and shop stockroom full of various types of hand tools. There are also things like pallet jacks and just material racks that have material on them that could present an injury if you're climbing on them, or even if you're handling the material improperly without your gloves. The steel can pinch your hand and give you a blood blister instantaneously. So everything, no matter how benign it may seem, will require some form of training. That training may be as simple as me showing you how to turn on the ventilation system and how to turn it off, or it may be much more complex. But make sure that you're properly trained on every single thing that you operate here in the shop. Just because you used it at home doesn't mean you can use it here. In terms of gas cylinder safety, you can see gas cylinders behind me, high pressure cylinders, and you can see oxyacetylene setups on the other side. We will cover gas cylinder safety specifically in another component of the program. But the general rules for gas cylinder safety are going to be as follows. High pressure cylinders are potentially very dangerous. If you are to move a high pressure cylinder and that cylinder is full, that move needs to happen with a cart. The cylinder needs to be chained to the cart and the cap on the cylinder needs to be installed. When removing a cap from a cylinder to put on a regulator or flow meter, you want to make sure that you are removing that just with your hands. You can actually hold the cap, and you may have to tap the cap lightly with a mallet to get it to start moving because the threads will rust up. But you don't stick anything inside the holes in the cap and pry because you can damage the brass valve on the inside. Once the cap is removed, the valves need to be open 100% or closed 100%. The valves that are on those high pressure cylinders are a double seat valve, so they are only fully sealed when they are all the way shut or actually all the way open. We don't ever move those cylinders when there is a regulator attached or when the cap is removed, okay? And those cylinders contain phenomenally high pressures, 25 to 2,800 pounds per square inch. And when you figure the number of square inches that there are on the cylinder, there are millions of pounds of overall pressure, raw pressure inside that tank. So they can be very dangerous. And again, we'll cover those specifically in another portion of the program. But it's very important right now that you recognize that they are basically a bomb if treated unsafely. Here in the shop, we don't have much in terms of confined spaces, although you will work with confined spaces or work in confined spaces out in industry. That having been said, it is important to recognize the dangers of confined spaces. Anytime you have a small access hole like a manhole cover or something similar, there is a chance that that space has an atmosphere that's unsafe to breathe. So that space would have to be ventilated properly. At the shipyard, for example, here in Bath, Maine, down at Bath Iron Works, the lab would actually come down and they have a device that they use to quote unquote sniff the air, and that would determine whether there is any type of toxic or dangerous gas, or maybe the lack of oxygen in that environment, which could lead to someone stepping in and suffocating or passing out. We do deal with argon gases in welding for shielding gases. Argon is heavier than air, so if it gets into a low area, perhaps there's a leak in a cylinder or a hose, that argon gas can displace air and you could actually drop into that space, take a breath, get no air at all, and have your lungs fill with argon, and you could die there on the site. Now that's obviously not an issue here in the shop. The shop is extraordinarily large, and even if we had an argon cylinder completely empty in the shop, and by some miracle the shop was air or argon tight and the argon couldn't leak out, the volume of gas would only fill the floor about this deep. So you're not likely to have that type of an issue here, but again, it is something to be wary of out in construction. So that having been said, one of the things that we will look at, again, when we get into gas safety are gas leaks, and we'll be very careful to check for them, because while it may not pose a danger here, it could very well pose a danger someplace else. Welders are, by very definition, performing hot work operations. Hot work operations in the trades will often require what's called a hot work chit. Essentially, that means that someone who is authorized, probably not you, but a trained lab technician, could be your foreman or someone similar, has inspected the work area and deemed that it's safe for hot work. That means that there's nothing in there that's going to catch on fire, primarily, but also there could be explosion hazards. There could be something as simple as the opposite side of the wall or bulkhead, if you're on a ship that you're working on, has been painted and insulated, and you might damage the paint or insulation on the opposite side of that work area. It's important to know what you're welding on and also what's on the other side. So when you're working in industry, in a shipyard is a good example where everything that you're standing on is welded. The floor or bulkhead, the ceiling or overhead, the walls, the decks, everything. You might have to weld on any of those surfaces, and you may not know what's on the opposite side. So that could, in fact, require a hot work chit. You may have a fuel tank on the opposite side of the bulkhead that you're working on. You may just have a situation where there's a potential for a finished space, which has been signed off, and deemed this area is complete, to be damaged or filled with smoke. So in addition to a hot work chit, you may have to have someone stand fire watch with an extinguisher to make sure that that work is being performed safely. And the fire watch could involve someone on the other side of the wall that you're welding on and in the space where you're working if there is a potential for hazardous materials in those areas. As a general rule, flammables need to be kept 35 feet from the area in which you're welding, and that safety rule is there to, again, prevent fires, which could be very, very dangerous in a construction environment. Ventilation. Ventilation is one of the more important things in a welding shop. The ventilation system in this shop is loud. It's really loud. So you'll know if it's not running, trust me. But welding will require ventilation even in cases where you're not producing a lot of smoke. Again, if you're welding with a TIG welding process, gas tungsten arc welding, where there really is almost no smoke, virtually no smoke, you still have argon gas that's coming out of the torch that could collect at the floor or collect in a small space. So even if you're working with a process that doesn't really produce much in terms of smoke, you still require ventilation. If you're working outdoors, the wind will be your natural ventilation. You may find that on a calm or still day that you need to set up a fan to keep the smoke from blowing up into your hood, just naturally rising up into your hood. If you're inside, there are specific ventilation requirements for welding. Direct or forced ventilation, often referred to here as just sucker tubes, okay, are going to be used to remove the smoke from the area in which you're welding. The sucker tubes here in the shop are a 4-inch vent line, and again, we will go over ventilation specifically in another video. But as an overview, you can see behind me that every booth has a vent line coming down into it, and on the end of that line is a flexible hose. That hose will be placed directly over your work to ensure that the smoke is pulled out. The welding smoke produces toxic fumes. Obviously, you're welding on metals. You could have paint coatings that you're burning, for example, and that wouldn't be the case here because we're welding on new material. But you've got iron and metals. You could have cadmium, beryllium, lead, hexavalent chromium on stainless steel. There are all kinds of things which you don't want to get into your lungs. Additionally, grinding will produce a great deal of dust and debris. Not only the metal that you're cutting, but the grinding disc itself is disintegrating and turning itself into a dust that's flying through the air. So ventilation is very, very important here in the shop. If you're working on the fabrication tables or on the shop floor, say we're producing something that's too large to be built in a booth, we will bring those sucker tubes over to you with extensions that come in 25-foot lengths. It's also important that the welder recognizes that, occasionally the shop will actually get a little bit smoky because people aren't using their tubes properly, and that smoke will rise to the ceiling. So it may be necessary to simply open the overhead door and let some fresh air in. I personally like to keep the overhead garage door up as much as possible here in the shop. I generally don't get many complaints from the welders. In fact, it's the students who usually ask if they can open the door. Maybe it's just because they like to let some sunshine in. Maybe it's because it helps the noise of the ventilation system escape, or because they just want to step outside periodically and get a little bit of fresh air. But it is definitely a requirement. Now, in terms of the specific requirements for ventilation, if you are welding in an area that has ceilings lower than 16 feet, which isn't the case here, or a volume of 10,000 cubic foot per welder, forced ventilation is going to be required. I would say that in general, if you are producing smoke from welding that cannot immediately be blown away from your face by the wind, you want to have a sucker tube. We also have a grinding booth here in the shop. The grinding booth is basically its own ventilation system. So I encourage students as much as possible to utilize the grinding booth if they're doing plate prep, as it is basically a self-contained space that will allow the students to turn on the ventilation system. It's basically like a downdraft, or it's like a paint booth, I guess you'd think of it that way, where it will pull the smoke through the back wall away from the welder. It goes up into the upper part of the unit and ultimately will filter and then recirculate back into the shop. So it also helps to control the noise of the grinders because it is a steel enclosure, and once you go inside, it does a pretty good job of muffling the sound of the grinding, although you can hear the booth running. But I think one is less annoying than the other. Personal protective equipment is something that is typically referred to as simply PPE. PPE can consist of anything and everything that's required to protect you, the employee, or the student in this case. That PPE in a welding shop would typically start with safety glasses. Students will be required to wear safety glasses and/or side shields on their prescription eyewear in the shop. They can wear goggles that cover their prescription eyewear, but some form of eye protection is required. Additionally, a grinder face shield may be required for certain grinding applications or torch cutting applications. In terms of welding, the welding hood provides face protection. Now, it's important to note that a welding hood, which covers your face, is not eye protection. So don't confuse one with the other. Eye and face protection would be required if you are, in fact, welding or grinding. Additionally, welders will wear green shop coats. Those shop coats will cover up their regular clothing, like the shirt, or I have a jacket on right now. The shop coat is a cotton material that has a flame retardant coating or chemical applied to it to prevent it from just bursting into flames, and that shop coat alone could literally save your life. Shirts need to be at least a minimum of quarter-length sleeves, so t-shirts would be allowed, but again, the shop coat would be over those shirts whenever you're doing any form of hot work. And grinding is hot work because you're producing sparks. Gloves on your hands will be required. There are specific types of gloves for different operations. There are heavier gloves for welding and cutting operations, and then lighter gloves may be required for just material handling. But again, gloves will be required at almost any time that you are working in the shop. In terms of outer clothing, you just want to make sure that your clothing is made from something like cotton or denim, which is cotton, linen, canvas, anything like that. You don't want to wear synthetic materials that can melt to your skin. It's very important. That you also consider that your clothing is in good condition. So if you have jeans that are, distressed, that seems to be all the rage nowadays, those are not allowed in the shop. The frayed edges will catch fire and you will sustain an injury. Additionally, they don't provide protection to your skin for sparks. Footwear requirements in the shop will include that of safety-toe shoes. Now, they don't have to be steel-toed shoes per se, but you need some form of a safety toe. It could be a composite toe. But sneakers or rubber boots, unless they have safety toes, I have some, which would be legal here in the shop, are not going to be allowed in the shop because we are dealing with heavy materials, especially when students are working on vertical and overhead positions. It is very easy for a piece of steel, which not only is heavy but also very, very hot, to fall and hit the floor, and again could also hit your foot. If you have the ability to get shoes with metatarsal protection, and those shoes are required at Fisher. If you happen to get a job down at Fisher building snowplows, you will be required to have boots with metatarsal protection or wear metatarsal coverings on your boots. You feel kind of like a knight putting on a suit of armor. But again, those requirements are there for reasons. Fisher does not want their employees injured. And they are working on booths with small parts. But again, if a small part falls from just a few feet and hits the top of your foot, it's going to hurt, okay? So the general requirements are that you are completely covered up from head to toe in something that is flame retardant, that you have eye protection on. Hearing protection is required in this shop because it is so loud. And I would recommend it in general, even if you're grinding and that grinding is intermittent. You may be well inside of the safety requirements or the recommendations from, say, OSHA for hearing protection. 85 or 90 decibels for less than 8 hours. In theory, you're safe. But the reality is not only does those earplugs protect your hearing, but they also will prevent sparks or things from getting into your ears. You can get an ear infection, outer ear infection, just dirt and debris inside your ears, which, like it or not, your ears have earwax in them, and that wax will collect all of the metallic dust in the air, and you can get a nasty outer ear infection, which I've had once in my life, and I wouldn't want to have it happen again. So eye protection, face protection, ear protection, outer clothing protection, foot protection, hand protection, all required in the shop. All right, so let's take a minute and talk about welding hoods specifically. As a general rule, most people nowadays are using some form of a electronic hood. This hood has a filter plate which you can see through initially, okay? It looks like you're wearing a dark pair of sunglasses, but you can see my hand through there. And as soon as you strike an arc, that hood will turn as black as this lens right here. So you can't see through this at all. These lenses are referred to generally as filter plates. Now the older style hoods, and I have a few in the shop, I have one student actually that prefers them. The old style hood, you simply flip the front lens up. This will cover your eyes. When you flip it up you can see, and when you flip it down you're ready to weld. They take a literal glass plate that will go in and provide that protection to your eyes from the bright intensity of the weld. These plates are going to be numbered, okay? And basically the higher the number, the darker the plate is. On the low end, you would have the lens here on this auto darkening hood that you can essentially see through, okay? It's like wearing a pair of sunglasses. It's a little bit darker maybe than your average pair of sunglasses, but that would be a shade 3 lens, okay? If you take a face shield that's intended for torch cutting operations, and let me grab one. So here's a torch cutting face shield. This face shield would simply be worn on your head, and when you're torch cutting you would flip this down. And I know it looks dark in the lens, but you can see my face through it, and if I simply turn this around you can see clearly that you have visibility through that lens, okay? That is a shade 5 lens, and that is the shade that you would typically wear for oxyacetylene cutting. From there, the shades will get darker. Anywhere between a 5 and an 8 would be suitable for plasma cutting or torch cutting. In terms of welding operations, typically you're going to jump right to a 10 as a minimum. There are shade 9 lenses out there, and I'm sure they have some purpose. Perhaps if you're TIG welding and you're doing very tiny work, little spot welds, perhaps a shade 9 might be handy, particularly if you're outdoors with this backlight coming in from your hood and it makes it harder to see. But as a general rule, for the type of welding we do here in the shop, it's really important that you have your hood set on a shade 10 minimum. Now these hoods, and again, this one has got digital adjustments, buttons on the inside. Some of these hoods, like this old Pro Hobby hood, has analog adjustments. There's literal knobs in here that you will turn. So a student could, in fact, have a hood turned down to 8, which is the lightest that those go, and weld. But you're going to damage your eyes, and you're going to find that it's going to be very difficult to see where you're going. It's actually too bright, so it's like trying to drive down the road with the headlights of another car coming towards you. So shade 10 is where I would say would be the minimum. Shade 12 is generally the darkest shade that most hoods will offer. Now this particular Miller hood, this T94 series hood, goes up to shade 13. If I had a situation where I was carbon arc gouging with 500 or 600 amps on a 3/8 inch carbon, and I was in a relatively dark space where the light from the hood was the only thing really coming towards me, perhaps I'm in a tank where I've got maybe some drop lights behind me, but the illumination isn't very good, a shade 13 may actually work very well. I can say that for the first 4 or maybe 5 years that I welded, I used a shade 12 all the time. I don't know that I could do that anymore. I like a little bit more light coming in. I'm also older. My eyesight is not nearly as good as it was when I was 18 years old. But as a new welder, it's important that you experiment with those shades. I would generally say, to start with, I would put your hood on an 11. Okay, that's generally a good compromise. And if you really can't see what you're doing with an 11, then you might turn it down to 10. But also, you might consider turning it up to 12, which is darker. And that sounds counterintuitive, But the reality is that sometimes that darker shade takes some of that brightness out of the arc, and it actually gives you better visibility. So it's really the equivalent of having someone come towards you with their brights on at nighttime, and then when they flick to their low beams, that would be like switching from maybe a shade 12 or a shade 10 to a shade 12. So when that darker shade is in use, it might take a couple of minutes to get used to it, but after a very short period of time, you may find that even though the arc isn't as bright, you can see the clarity in the puddle of steel a little bit better. You may also discover that you don't need to see a foot in front of you or a foot behind you where you're traveling, because it's really the visibility of the puddle that's important. So again, shade 5 for Oxy-Fuel, shade 8 for plasma, somewhere in that range for those two, and a shade from 10 to generally shade 12 for your regular welding hood. All right, on the subject of hearing protection specifically, I provide earplugs for students here in the shop. I generally have a couple of styles of earplugs. Not everyone has the same size ear canal, so there are smaller earplugs and larger earplugs. The larger earplugs may seem like they quiet things down too much, but basically what they do is they take out the background high frequency sound and allow you to hear voice communication a little bit easier. So putting in a pair of earplugs that's too small, and my ear canals are relatively large, so the smaller plugs here in the shop really don't help me all that much. They obviously do reduce the overall noise level coming in, but they don't effectively filter out the high frequency sound, and I actually can hear better with the larger, more tight-fitting earplugs in. Earplugs are required in the shop because the noise levels in the shop here exceed 85 decibels. Just with the ventilation system on, the noise levels exceed 85 decibels. Inside the welding booth with a needle gun or a pneumatic scaler or a grinder, the noise levels can exceed 100 to 110 decibels, which is going to be damaging to your hearing in a very short amount of time. Additionally, hearing protection is required in most production areas when you're performing hot work because, again, they keep sparks from entering into your ears. Now, one common misconception is that earbuds, noise-canceling earbuds, are hearing protection, and they're not. Noise-canceling earbuds are capable of creating a sound signature, a wave that is 180 degrees out from the original wave. So if you imagine you have a clear, pool of water, and you tap the water on one side, you get a ripple that goes across. If you tap a ripple on the opposite side, when those two ripples collide, they basically cancel each other out. So your earbuds can take a background noise, like the hum of an air conditioner or something like that, and that noise level is not really all that loud in terms of what we call decibels, which is how we measure sound. The decibel level of that is not all that loud, and the frequency is such that the electronics in your earbuds can replicate that, and then it can basically mirror image it or flip it. And your earbuds basically sense that incoming sound, they hear it, they replicate that sound 180 degrees apart, and then they produce that sound into your ear. So the noise-canceling hearing protection is putting noise into your ear. Now that noise is canceling out, effectively, the hum of the air conditioner. But the limitation is that the earbuds have to be able to create the sound at the speed at which it's coming in and at the decibel level at which it's coming in. So your earbuds have tiny little itty-bitty batteries in them, and they're not physically capable of replicating a needle gun and flipping that sound and canceling that sound out. Additionally, the only reason you would typically have earbuds in is to listen to music. And music is typically listened to at a minimum of 15 decibels above background noise. Now for reference, and again we'll talk hearing protection specifically some other time, but for reference, with the decibel meter, and I'm not talking about my cell phone, I have an actual decibel meter, in my classroom with all the doors closed and the students being as quiet as they can, the noise levels in the classroom are 52 decibels, okay? So if I go from 52 decibels to 85 decibels, it doesn't seem like that much in terms of numbers, but every 5 points, I believe it is, on the decibel scale, the sound intensity doubles, okay? So from 52 to 57, it's twice as loud, okay? We go from 57 again up to 62. It is now 4 times louder than it was at 52. So that sound intensity doubles. And essentially, when you put your earbuds in a dead quiet room and you're listening to music at what would be considered normal noise levels, obviously there's minimalist, you can barely hear it, but at a noise level that people would typically associate with music, and I don't mean teenager loud, but just normal noise levels, you're going to have difficulty hearing conversation that's happening in that room. And that is because, and this is with normal earbuds, I'm not even talking noise canceling, and that is because that sound level has now gone up by about 15 decibels, which means it's 2 times 2 times 2, it's 8 times louder than the background noise that you had in the room to begin with, okay? So it is very, very important that you recognize that earplugs, the foam earplugs or ear muffs, which don't fit under your welding hood, so as a general rule, earplugs are what is used, are the only solution for noise. Earbuds, earmuffs are not allowed in the shop. And to that point, cell phones aren't allowed in the shop either. So your earbuds don't really make that much difference. Hazardous substances are something that we have to deal with in everyday life. And there are things that you may not think of as hazardous. Bottle of Windex, window cleaner, for example, furniture polish, hand lotion or hand cream, soap, okay? Everything in this shop has a hazard level associated with it. And we have a material safety data sheet, or SDS, safety data sheets as they're commonly referred to today, for everything that's in the shop. So if you come into the shop and you find a chemical, and that could be a roll of welding wire, it could be something that you would commonly think of as a chemical, like a jug of acetone, degreaser, brake cleaner, which we use sometimes for cleaning small parts. Everything has what we call an SDS number on it, and you can contact the manufacturer of that item, and there is what we call an SDS sheet. The SDS sheet is simply a form that is set up in a standard format that gives you all of the information you need to know about that particular chemical or that particular hazard. So in some cases, you may have a liquid, say Windex is a good example. It'll tell you, the specific gravity of that fluid. It'll tell you what color it is. It will tell you if you need to wear gloves when you're handling it, if it's safe to drink, if you should induce vomiting, if it is swallowed, or what happens if you get it in your eyes. It will have a chemical makeup of that material. It will have precautions that you have to take with that material in terms of usage, storage, everything. It's all on that sheet. So those sheets in the shop are located on the wall near the classroom entrance behind the plasma table, and they are available to you to take a look at any point in time that you choose, okay? It's important that you understand and recognize the safety risks that you're putting yourself at. So familiarize yourself not only at the job site, but here. I'm not going to intentionally put you in any form of harm, but recognize that you can get cancer from sunlight, so there is harm to virtually everything in your life. The real trick is recognizing the risks and what the danger levels are and how to deal with those appropriately. In the shop, we will occasionally have to use solvents or degreasers to clean material. That is particularly true when we're TIG welding aluminum. So in the process of welding, most processes will produce some form of oxidation removal. There are fluxes and flux core welding and in stick welded, shielded metal arc welding that will allow for some amount of oxide removal and some amount of base metal cleaning. TIG welding really does not. Because of polarity, the cleaning that happens electrically is at the tungsten, not at the base material. And because of materials like aluminum and stainless steel that oxidize rapidly, the oxides have to be physically removed, and in case of stainless steel, the material has to be almost surgically clean in order to get a good weld. Well, in the case of aluminum, I guess specifically, but both materials may require extensive base metal cleaning. So we will use chemicals to do that cleaning. Now, there are other times when we would perhaps want to clean something. There may be times where you have to weld on a container that may have had something in it previously. Maybe you have a barrel that you're going to convert over into a barbecue. It's very important that you recognize what was in that barrel before, because there could be remnants of that which could be toxic if you weld it. So when you have something that needs to be cleaned prior to welding, you want to make sure that you get someone who is authorized to do that type of work on a job site, or at a minimum, if you're doing it on your own, knowledgeable as to what that is. I would say that, if you're not sure of how to properly take care of something or clean it, and you have no other resources available, I would get on your computer and I would try to look up, the proper cleaning method for whatever it is that you're trying to work on. It's not worth the risk. Even a container that appears to be empty, or you may assume is empty, could have hydrogen gas on the inside from the rusting process. If it's steel or iron, it could have rusted, and welding on that enclosed container could literally turn that into a bomb. So it's very important that you understand what you're cleaning it with, and the proper methods that are associated with that. As I've said earlier in this video, we will talk about Oxy-Fuel safety specifically in another training on Oxy-Fuel cutting. But there are some general precautions which everyone should recognize. First of all, acetylene or any type of fuel gas is potentially dangerous. Acetylene is particularly dangerous if not used correctly, because the flammability limits are very, very wide. Most fuel gases, such as propane, like you would have at home, can be actually difficult to light. They require a very specific amount of oxygen, too little or too much, and they simply will not burn. But acetylene will burn in almost any amount of oxygen. So you could have oxygen levels as low as a few percent to as high as almost pure oxygen, and acetylene will still burn. So we want to make sure that we have no leaks, that we're checking our tanks for leaks. We also want to make sure that the oxygen is not treated as air. Okay? There is oxygen in the air that you breathe, 20% ballpark. The rest of it is made up of nitrogen, argon, other gases. But oxygen in a cutting operation is pure oxygen. Now, oxygen does not burn. That's a myth created by the movie industry. But oxygen will make anything that burns burn like crazy. So in an environment of no oxygen, nothing can really burn unless it provides its own oxygen. And there are a few things, rocket fuels, and there are a few other metals that will do that. I believe nitromethane for racing fuel has oxygen in it, so it will burn very rapidly, okay? But most things will require an external source of oxygen in order to burn. So if you have a cutting torch and you press the lever and you get that jet of oxygen, you might be tempted to use it to blow some dust off your clothing, or maybe it's hot in the summertime, you kind of blow it on your face. Recognize that you can saturate your clothing with oxygen, and then after that a simple spark could send you up in flames pretty quickly. And not that you're going to burst into flames like you've been doused in gasoline, but the idea is that if you have lint or dust or anything like that on the outside of your clothing, it can flash over pretty quickly and you can get some pretty severe burns. All right, so let's talk arc welding safety. That is basically what we're here for. In terms of arc welding safety, there are a lot of things that you have to keep in mind. One of the first things is that your equipment is energized by electricity. So you want to make sure that before you get started that you check your equipment out, check your connections. Even here in the shop where the equipment is largely stationary, leads, hoses, cables, and even main power plugs are disconnected to plug in other equipment because there's a limited amount of stationary power in the shop. So you want to make sure that your power cords are in good serviceable condition. You want to always check your plugs. On our shop, we have smaller 14-pin plugs in the shop that connect the wire feeders up to the harnesses that go back to the power supplies. While the voltage there is relatively low, it's important to make sure that the outer part of that plug is turning and not the basket end where what holds the wire, because you can twist the wires off and you can damage the plug. You want to make sure that your main leads are physically tight. A loose connection is where heat is generated. Heat could generate a fire, although I think that's unlikely in terms of a welding cable, but it certainly happens in homes all the time. Loose connections burn houses down. In welding, it will simply make your machine weld inefficiently, and you may find that you have issues that you didn't have if the connections were simply tightened. You want to make sure that if you find something that's defective, that you have someone who is authorized to fix that. Go ahead and make that repair. Don't assume that you are knowledgeable enough or authorized to fix that issue. There's so many things that make noise in here. It's important to make sure that your equipment is grounded. Now, the grounding of the equipment is not the same as the work lead or ground clamp that's on the other end of the machine. Proper grounding is to make sure that the electrical service that's hooked up is set up correctly. On a trailer, that may mean that the welding machine has a physical ground to the trailer or a physical ground to your pickup truck, and then the actual work clamp that is the return path for your circuit is properly connected to the material that you're welding. You want to make sure that the work clamp is connected on the side that has the copper cable, and you want to make sure that the material that you're connecting to has been ground clean. I've had students clamp work leads or ground clamps, I'll use them interchangeably, but work lead is the correct term, to their booth bench top on an area where the bench top is painted, and then wonder why their machine is not welding good. When I move the ground clamp, I can show them the arcs and sparks where it's tried to burn through the paint. So that generates a considerable amount of resistance, and that's going to change the way that the machine actually welds and operates. You can take a machine that's running very poorly and simply move the ground clamp or work lead to a clean location, and without changing anything else, all of a sudden it runs very smoothly. So it's important to make sure that those are connected tightly, securely, and that the connections are clean. Obviously, you want to make sure that you have on the correct personal protective equipment for the welding operation that you're performing, that you have the right gloves. I guess that means I gotta go. Other general concerns when welding for general safety is making sure that when you are through stick welding that the electrodes are taken out of the electrode holder because they're still electrically live. You also have to be careful where you set your MIG gun down. If you place the MIG gun on the table, it can slide off the table. The trigger will hit the edge on the way by, and again, it will arc out. It's also possible to place your MIG gun down so that the trigger is touching something and it just continuously feeds wire. Additionally, you want to make sure that your machine is in the correct mode and that the opposite end of the machine is set up correctly before you turn the power on. An example of this would be having a MIG gun that is placed in the holder in the booth and the nozzle falls off. If the nozzle falls off the MIG gun and the MIG gun is in the holder, the end of the MIG gun will be electrically connected to the booth, when otherwise it would be insulated by the nozzle. If you set your machine to stick mode and then turn the power on, you will instantly weld the MIG gun to the booth, destroying both the booth and the MIG gun. MIG guns are $400, $500, $600 or more in some cases. So it's important to make sure that that's set up correctly. Additionally, if the opposite end of your electrical connection for welding is not known, if you don't know where the other end of that cable is and you don't know the condition of that cable, you could turn the power on and have a lead that is damaged start a fire in a space that is not within your sight or your hearing. So it is very important to make sure those things are set up correctly. Hopefully it goes without saying that you want to make sure that you're not welding in an area that's wet. You don't want to stand in water and have your electrical ground unconnected for any possible amount of time, because there's a possibility that you may become the electrical ground. Electricity will take the path of least resistance, so if your machine is properly grounded or the work lead is properly connected, then that will be the path of least resistance. But if you have a poor ground and you're in a wet area, you can become the ground and you can electrocute yourself. When you're through welding for the day, turn the machine off. Even if you walk away for a short amount of time, it's worthwhile to turn the machine off, as the machines draw a considerable amount of power in some cases, even when they're static. Particularly if you're working at your home and you have an older machine that you've bought that you can plug into household current, you'll find that those older machines use a lot of electricity just sitting there idle. So turning off the machine when you're not in use will save your electric bill. It also means that an accident is less likely to occur. You want to disconnect the power if you're making any type of a repair. The 14-pin connection on the wire feeders has a 24-volt circuit that runs the motor. It will also run the gas solenoid and other things that will be necessary to check for function. But you do not need the large main welding cable connected, so disconnect that cam lock and pull it apart so that you're not getting welding current through to the machine. It's much safer that way. If you are changing polarity, it is a good idea to also disconnect the power. You have to disconnect the leads on the front of the machine on the Miller XMT series to switch polarity. Other machines will have a simple switch that allows you to change for polarity, and while it may not seem necessary, it's a good idea to turn the power off when you're doing that as well. If you are working in a space where you don't have a bench or table to work off of, and perhaps you're welding on the floor, you want to be especially careful. Welding on a concrete floor can cause the concrete to be damaged or even explode. Now, I'm not talking about a massive explosion in all likelihood, but it will certainly cause damage to the floor, and some of that damage can be quite severe. So if you're welding over concrete and you have a piece of material that is directly on the floor and you run a bead on top of it, the red heat that is visible on the backside of that weld, which is 1400 to 1700 degrees in that range, or more in some cases, will heat the concrete up and cause the tiny air pockets within that concrete to expand so rapidly that the concrete actually blows open. In the case of Oxy-Fuel cutting, if you're cutting over a concrete floor, you want to put at least a piece of sheet metal down to protect the concrete from the direct sparks, as it will damage your floor. Now, if you have an older floor that's pitted and you don't care about it, again, it may not seem like a necessary step, but it's worthwhile. The floor will get worse, okay? So if you have a brand new floor like we have in this shop, you will definitely pit the floor, and it will make the floor harder to maintain and clean in the future. When selecting your electrodes for stick welding from the oven, bear in mind that it is an oven, and that oven is set at about 350 degrees, and when you reach in there, those electrodes are going to be hot, so you want to make sure that you have gloves on. Those electrodes will eventually cool off to room temperature, but for a period of about 15 or 20 minutes, maybe more, depending upon how many electrodes you grab, the wire is still going to be hot. Also keep in mind that if you weld for a few minutes with an electrode, or a few seconds with an electrode, and that electrode is set down, and then you intend to reuse it later, that electrode itself will be electrically preheated from the welding process. So even though the wire has been out in the open for several hours and is otherwise cool, an individual welding rod will be hot. So if you burn half of it and then you go to take that wire out without your gloves, which obviously you shouldn't do, that electrode will be very hot. This can easily be demonstrated by simply grounding the electrode out using a machine that has a 100% duty cycle, and you will see the electrode turn orange as it goes. It will basically turn into a toaster element. The same effect happens with MIG wire. When you pull the trigger, if several feet of MIG wire extends out of the gun, you'll have almost no voltage, but you have a lot of amps. And essentially that entire length of wire will turn orange almost instantaneously. It's also important to keep in mind that on your MIG wire, while it will not be hot per se, it is electrically hot. So even the wire on the spool on the back end of your feeder, when you pull the trigger to weld, that wire is electrically hot. So if something were to lean up against that wire or touch it, it will arc out and it can damage the wire, damage the equipment, start a fire, or potentially get you electrocuted. So you always want to be really careful when you're working with these things. So let's talk about different classes of fires and fire extinguishers. The most common type of fire extinguisher, and the type that we have here in the shop, is a Class ABC fire extinguisher. There's a fire extinguisher that is in the classroom, and again, there's a signage up above it. It's right below the whiteboards. And there are 3 fire extinguishers here in the shop and 2 fire blankets. So the first fire extinguisher is at the front wall between the classroom entrance and the stockroom entrance, and it's built into the wall, and it's encased, the little door right there. There's a fire blanket inside that case, and additionally there is a fire blanket above it in a pouch, okay? Please don't pull that fire blanket down, because you'll have a heck of a time folding it up and getting it back up in there. But trust me, it is there. And if someone were to catch on fire for some reason, you would get them on the ground, cover them with that blanket, and put the fire out. The other fire blanket is on the end of booth 13, and directly across from it, on the side of the grinding booth near the drill press, is another fire extinguisher. The final fire extinguisher is in the window opening, or below the window opening, close to the carpentry shop entrance on the right-hand side of the shop. And again, it is clearly marked with signage. All of these extinguishers are of type ABC. Now, a Class A fire is basically a common fire from wood, paper, or trash. It is a type of fire that could easily be extinguished with water. Now, if you caught on fire, your clothing, you could probably easily be extinguished with water as well, but the likelihood of there being a hose readily available is slim. So the fire blanket would be a good way to put someone out. You could, pat them up, pat a small fire out if your tail of your shirt caught on fire or the cuff of your pants. But if you had a major flame up, which I've never seen happen, but I'm sure it has someplace, the fire blanket would come in handy. In the event that you should need to be put out with water, or if you get chemicals on you and you need to be rinsed off, there's an emergency eye wash and rinse station. As you can see, the emergency eye wash station, while potentially a benefit, makes a huge mess. So if you catch yourself on fire and you need to put it out, or if you get chemicals on you and you need to rinse them off, please make sure that you use it, but don't pull the handle unless absolutely necessary, because this is now a slipping and tripping hazard. The Class B fire would be liquid flammables, okay? So think gasoline, oil. A Class B fire is not going to be able to be extinguished with water, so it requires a dry chemical extinguisher. And that is because the water will spread the fire, okay? It will spread the liquid that's on fire, and it can cause a massive increase in the amount of flame that you have. So you never, ever, ever want to put water on a Class B fire. The Class C fire is an electrical fire. Now, an electrical fire is very, very different from a Class A and a Class B in that A, you don't want to put water on it, and B, the intensity of the flame is very, very high. So if you think about a welding arc, which is essentially a controlled electrical fire, we have an arc temperature of thousands and thousands and thousands of degrees Fahrenheit, 5,000, 7,000, up to 15 or 20,000 degrees in case of a plasma arc. So that fire is going to be difficult to put out. Additionally, on an electrical fire, you may have a situation where the power that is being supplied may still remain on. If there's a faulty breaker, or depending upon how the system is set up, you could have an electrical fire that's the result of a welding machine, in which case there is no circuit breaker. The machine just thinks you're welding, so it's just going to keep pumping electricity in until someone finally turns the power off. So once the power is turned off, you would again use a Class C fire extinguisher, which is commonly carbon dioxide. So in the shop, we may have a fire that could be extinguished by water, we may have a fire that could be extinguished by some sort of a dry chemical, and we may have a fire that could be extinguished by straight carbon dioxide. Rather than have 3 extinguishers and having to think in the moment, we have Class A, B, C extinguisher, which is basically a pressurized canister full of common household baking soda. That having been said, you don't want that sprayed into your face or your respiratory system, your lungs, your mouth, or your eyes, so you do not put out another human with a fire extinguisher of that type unless there's absolutely, positively no other way to do it. The fire blanket would be the first choice. The next classification of fire would be a Class D fire. A Class D fire is a combustible metal. Yes, there are combustible metals. Magnesium is a great example. You can go to your local camping supply store, Walmart, hardware store, and buy little magnesium fire starters. Those fire starters operate by simply scraping some magnesium off of a block. On the opposite side of that block, there's a flint glued in, and you can take the back of your knife, or sometimes they're supplied with a little, looks like a big piece of bandsaw blade, and you can simply scrape that. That magnesium will burn very easily when it's in fine concentration, like metal shavings, and it burns extraordinarily hot. If you were to light the entire magnesium block on fire, there's virtually no way to put it out. It would have to self-extinguish. And it will burn with an intensity hot enough to melt other metals around it. So it's very, very, very dangerous. We have no means in this shop of extinguishing a Class D fire. Now, we also don't work with metals in this shop that are flammable. We don't weld on titanium, and we don't weld on magnesium. But if you're ever welding on something that you think is aluminum, a white metal, so to speak, you know, the quote-unquote white metal, you want to make sure that you research and discover what that is. If you had any doubt, you would want to take a file and you want to file off a few shavings of that material and see if you can't get it to burn. If the shavings burn, you definitely don't want to weld on it. The last classification of fire is a Class K. A Class K fire would be a flammable liquid, but specifically we're talking about kitchen grease or oil. Class K fire extinguishers are not going to be found here. Class A, B, C extinguisher would probably put out a kitchen fire without too much difficulty, but again, Class K fire extinguishers, which are of a different type, more of a foam coating, are going to do a better, safer job of putting out those fires. And they will result in less likelihood of the fire spreading. Of course, the best way to put out a Class K fire in a lot of kitchen instances is to simply smother it by putting a lid over the pan. But if it spreads beyond that, again, an extinguisher will be required. And if you're working in a kitchen, you would likely have Class K fire extinguishers on hand. I will note that the small extinguishers that you buy at the hardware store for your kitchen, they're generally very small, just big enough to put out a little fire on your stovetop, are not generally Class K type. They are type A, B, C. If you have to operate a fire extinguisher, you want to make sure that you are aiming the extinguisher at the bottom of the flames, okay? Fire goes up, so the part that's burning is at the bottom of the flames. So you don't start at the top and work your way down. You aim that extinguisher at the bottom. You're going to simply pull the pin. You can't grip the extinguisher too tightly, or you'll actually pinch the pin and hold it in place. So calmly hold the extinguisher in your hand, pull out the safety pin, take the hose, aim the hose at the base of the fire, and then move that extinguisher left and right with a sweeping motion until the fire has safely been extinguished. At that point, you would want to call your fire department, contact your supervisor, whatever is appropriate for your particular workplace. Here at the school, you would definitely want to tell me if I wasn't within visual sight of it when it happened, and then I would contact supervision here at school, and we would determine, how that fire happened and how we could prevent it in the future. If there was any damage to the building or equipment, we would obviously have to report that immediately as well. All right, so this is the end of the shop safety overview for the program. This is basically the initial lesson that students would get on the first day, and if you're watching this as a student, it's because you weren't here, you missed this portion. But the takeaways here are a few. A, don't touch things that you haven't been trained on. It doesn't matter if you use something at home, you have to be trained on that item here. You have to have your personal protective equipment on really at all times. You're going to have something on at all times. If we're in the shop, at a minimum, you'll have safety glasses. If we're going over a lecture component like Oxy-Fuel safety, which we do here in the shop, you obviously would not have hearing protection on if the blowers aren't on when we're just trying to talk and communicate with one another. But you do need to make sure that you are wearing your steel-toed shoes, that you are wearing gloves when you're handling material. There are circumstances where you will not wear gloves, stationary rotary equipment, for example, and that's why we have specific training to cover the bench grinders, hand grinders, the drill press, bandsaw, so on and so forth. So the safety precautions for that specific equipment will be located in the specific training that you get. But as an overview of safety, just be mindful of the fact that you are working with stuff that's new, you are working with electricity, you are working with heat, you are working with materials that can fall on your foot, break your foot, pinch your hands, cut you, and in general, you just got to keep your wits about you, no horseplay, and be prepared to come in every day, learn something new, and act like an adult.